Hi everybody. So in this video, we're going to look at friction on an inclined plane. So a force of friction between two surfaces can be calculated using the formula F equals mu r. This mu is the coefficient of friction. This r is the normal reaction between a mass and the plane. So in this case, it'll be this r here. And the actual value of the coefficient of friction between two materials depend on their nature, and it can range from mu equaling 0, and this is where the two surfaces are perfectly slippery, and mu being greater than 1, and this would be where the two surfaces are extremely grippy. So as we work through the next few examples, we'll be using this idea to work out the different forces on an inclined plane. Okay, so if we look at example 1, we're told that a body of mass, 10 kilograms, is on the verge of slipping as it rests in limiting equilibrium on a rough inclined plane at 30 degrees to the horizontal. Notice it says rough here. This means that friction does apply. And we're asked to find the coefficient of friction between the sledge and the plane. So we're being asked to find mu. Okay, so we can start by considering this downward force of 10g. And this force will have two component forces, one which is perpendicular to the plane and one which is parallel to the plane. The one which is perpendicular to the plane will be the same as the normal reaction because these are in equilibrium. For instance, this mass is not moving up or down, so these two are equal. So we can call this one R as well. And because it's in limiting equilibrium, the downward force here, parallel to the plane, must be equal to the maximum frictional force, which we'll call F max. We can work out this force which is parallel to the plane using this right-angled triangle. So I showed you in a previous video how to work out these component forces. We know this angle is 30 degrees, which is the same as this one. And because this force does not contain this angle, this will be 10g sine of 30. And the normal reaction force, because it does contain the angle, this will be 10g cos of 30. So now we need to look at resolving our forces, and we'll begin by resolving the force that is downwards and parallel to the plane. We know it's in equilibrium, so the downward force will be equal to the frictional force. So 10g sine 30 will be equal to F max. And we know that this F max is equal to mu r. So we can say then that 10g sine 30 will equal mu r. And we can work out this r with what we've done here. So if we resolve these forces now perpendicular to the plane, we know r will be equal to 10g cos 30. So now we can substitute this value for r into here. So 10g sine 30 will equal mu r. So 10g cos 30. We'll divide both sides by this. So mu will equal 10g sine 30 over 10g cos 30. We can see that the 10g's will cancel, and sine 30 over cos 30 gives us the tan of 30 degrees. We can work this out on our calculators, and we get mu is root 3 over 3, or approximately 0.577. Okay? In example 2, we're going to take this a little bit further by working out an acceleration. Okay, so for example 2, we're told that the diagram shows a block of mass 20 kilograms which is initially at rest on a rough surface, and the force of 100 newtons is applied at 30 degrees to the horizontal. And we're given that the coefficient of friction is 0.5, and we've been asked to find the acceleration and the time taken for the speed of the block to reach 17 meters per second. Okay, so like we did in the previous question, we're going to resolve the forces both parallel to the plane and perpendicular to the plane. So if we begin by resolving the forces parallel, well, we know this 100 newtons will have a parallel component, in this direction of 100 cos 30, cos because it contains this angle, and it is this force which will cause the acceleration in this direction, which means there must be an opposing force in this direction caused by friction, which we'll call F max. So we've got then 100 cos 30 minus F max will give us a net force of ma, where the mass is 20 and we need to work out the acceleration. But now we need to work out F max, which means we need to resolve vertically. So F max is mu r. We know mu is a half, so we need to work out the normal reaction force, R, which is this force here. But we can also see this 100 newtons as a vertical component acting vertically upwards. And because it doesn't contain the angle, this will be 100 sine 30. So resolving vertically upwards, R plus 100 sine 30 must be equal to the downward force, which is the weight of this object, so 20g. We know the sine of 30 is a half, so this becomes 50. So R will be 20g minus 50, which gives us 146 newtons. So now we can substitute this value for R back into F max, and this will give us a half of 146, so 73. And this will be the opposing friction F max in this direction. Okay, so if we carry on then resolving horizontally or parallel to the plane, 100 cos 30 is approximately 86.6 minus F max, so minus 73, will give us 28. So 13.6 will equal 28. We'll divide both by 20, and the acceleration is 0.68 meters per second squared. Okay, so for part B, to find the time taken to reach 17 meters per second, we need to use our CVAT equations. So the displacement isn't relevant. The initial velocity is 0. The final velocity is 17 meters per second. The acceleration is 0.68, and the time is what we're trying to find. So we can use V equals U plus AT. So 17 will equal 0 plus 0.68 T. Divide both by 0.68. So T will equal 25 seconds. Okay. Let's try one more question. Okay, so in example 3, we're given that the diagram shows a box of mass 5 kilograms on a rough slope which is inclined to the horizontal, where tan theta is 7/24. And we're told that the box is moving down the slope with an acceleration of 0.8 meters per second squared. We've been asked to work out the coefficient of friction, and then the speed of the box and the distance travelled when it reaches the bottom of the slope. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So we'll begin by resolving parallel to the plane in this direction. So we know there's an acceleration travelling downwards, which means there'll be a frictional force travelling upwards. And we know this 5g will act both parallel to the plane and perpendicular to the plane. And this angle will be theta. So I'm going to actually change this so we are going down the slope. Okay, so we know the downward force, I'll call FD, which is this one here, minus F max, the frictional force, will have a net force of ma. So the first thing we need to do is to work out FD. And this will be the 5g times the sine of the angle theta. So FD will be 5G sine theta. But we haven't been given sine theta, we've been given tan theta. So if we have a right angle triangle, this is theta, we know this is the opposite divided by the adjacent, so 7/24. So using Pythagoras for hypotenuse will be 7 squared plus 24 squared. So this will be 25. So sine theta then will be the opposite divided by the adjacent, 7/25. And then we can substitute this back into here. So FD will be 5G times 7/25, which works out as 13.72 newtons. So I'll write this on a diagram, 13.72. So now we need to work out F max, and this is mu r. Well, we can work out the normal reaction using this component, and because this contains the angle, this will be 5G cos theta, and we can work out cos theta from this triangle. So cos theta will be the adjacent 24/25. So we can substitute this back into here, and we get 5G lots of 24/25. So R then becomes 47.04 newtons. Okay, so now we've got the normal reaction and FD. We can substitute them back into here. We've got 13.72 minus mu R, so mu times 47.04 will equal the mass times the acceleration. We're told that the acceleration is 0.8. We times that by 5 and we get 4. We can solve this equation. We'll move this to the right-hand side and this to the left-hand side. So we get 47.04 mu is 9.72. So mu must be 0.207 to 3 decimal places. Okay. And then for part B, we're told that the box starts from rest and reaches the bottom of the slope after 3 seconds. So we'll use our CVAT equations. S, we're trying to find. The initial velocity is 0. The final velocity we're trying to find. The acceleration is 0.8. And t equals 3. So we can find the final velocity. V will equal u plus at. So v will equal 0 plus 0.8 times 3. So v will equal 2.4 meters per second. Then we can work out the displacement. We can use s will equal u plus v over 2 multiplied by time. So this will be 0 plus 2.4 over 2 multiplied by 3. And this will give us 3.6 meters. Okay. Well, thank you very much for watching. I hope you found that useful. You can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.